Hello everyone, welcome back to my channel. So today we will be diving into the JavaScript important topic, which is closures. So at the end of the video you will able to know what are closures and when it will be used in the JavaScript, and this is a important topic which we used in our daily coding activities in JavaScript. So let's get started. So what is closure? Closure is a function that has access to variables in its outer lexical scope even after the outer function has finished executing. In other words, closures give you access to outer function scope from inner function. So basically, what are closures? When we have one function and inside that we have another function, so inside functions has access to outer function variable that is known as closure. So let's move to one example. So I have declared one outer function named outer function, right? And inside that I have one variable which is const variable, outer variable, and I have one inner function which is I am returning that inner function, and inside that inner function I am printing that variable which is the scope of outer function, right? So what happens here is whenever I call outer function, so outer function has finished executing now, right? So that outer function is returning inner function, and I have placed that inner function inside that const my closure, right? So this outer function has finished completed, and this outer variable has finished, but this inner function still has a reference to that memory, this variable, and this inner function can access that outer variable even if the outer function is already executed, right? So if I call this function inside function, so you'll see uh, outer variable is being printed, right? So it has access to the outer variable. So let's see lexical scope, the global scope, the outer function outer function has a global scope. My closure is also a function, right? Outer function scope, so outer function scope has a outer variable and inner function. So outer function scope has two things, variable and a inner function, normally destroyed after execution. Okay, so inner function scope has access to outer variable, create a closure. So whenever we call this outer function, so it create a closure with the inner functions, right? So we can access that variables inside that function. Function is executed using scope chain that was in effect when they were defined. Outer function scope is kept alive in memory because the inner function still references it, right? So outer function variable has not been destroyed, it's still in the memory because inner function has that reference, right? The inner function maintain a reference to outer scope variables. So let's move to one practical example. So suppose we have a counter application, right, in which there are buttons and we have to click increment and decrement counter. So we have created one function which is create counter, and we have one variable inside it, the count, right? So and we are returning a object here in this function. In the object itself we are having three functions. One function is increment, decrement and get value. So in the increment function we are accessing the count variable from the outer create counter function, right? And also with the decrement, also with the get value. So whenever I call this create counter function, it create and closure, and all the internal functions or objects can access this count variable, right? So I have count there. So whenever I do counter dot increment, it will count plus plus, it will access that count variable and increase that count and return that count, right? So whenever I console this, I'll see 1 0 plus 1. So whenever I console again this, will be 0 1 plus 2, because that count is variable is this count variable, right? So it incremented that variable only because that refers to the same memory address, right? So if we are now decrement that, it will show 1 to 1, right? So mainly the closure is something we can access the outer variables. So this is one practical example. Let's move to another practical example. So global scope, we have counter function which has increment, decrement and get value functions. Count is 0, private, only accessible through returned methods. Count is 1, state persist between after increment count to same closure, same variable, right? Common use cases: data privacy, encapsulation. Create private variables that cannot be accessed directly from outside the function, only through specific methods. So suppose we have to create a function, and inside that we don't want to access the variable directly because of the privacy. So we create like getter setter function in which we can get that count. Suppose you can see we have a get value function in which we are returning the count. So we have a get function here. So this get function is accessing the outer variable. So it is the example of closure. So whenever we want data privacy, we use closures function. Create customized function with preset parameters or value. So let's move to this example. Create customized function. Suppose we want to have a multiply function. We want to have multiply function, right? So we only want that the multiply should be multiplied by particular number, suppose 2. So if we have suppose we have simple function multiply by 2, and we are passing a comma b, right, and returning a into b. So every time we have to pass 2 multiply by 2, every time we have to pass 2 comma multiple, we whichever number we want multiple of that, right? Multiply by 2 2 comma 4, like this, right? So this is basically a we are replicating the things. We are again passing same argument again and again. So whenever we use closure, so this can handle this can create the customer function with preset parameters. So we can add one parameter, and inside that we return another function in which we can pass the number, and the multiplier here is one variable which can be accessed inside that function, right? So we have multiply by, we can pass 2 here, and we have a double function which is returning this function. So we can call anywhere the double function in which we can pass the any number, and this will return a multiple of 2 with this number, right? So this is basically also helps to create customized functions, event handles and callbacks, maintains state across asynchronous approach without global variables. So this also helps because it creates an closure, and that variable which is in the outer scope has already in the memory. So we don't want to create global variables every time. We can create one function, and inside that we can create multiple functions, and all that have access to that variable, right? module pattern, create modules with public and private methods properties. Right, so multiple independent closures. So if let's look at one more example in which we can create multiple closures. So suppose we have one function create user in which we have user score, right? So we have one function add points, right? And we are adding one score to that user score and consoling the name and user score here. So whenever I call this create user function and pass name, it will create a closure inside this, and all this variable will be accessible inside this function also. The name variable and user score will be accessible inside this function. So name is also in the outer scope and user score is also in the outer scope. So these two variables can be accessed in the inner function because of the closures. And whenever we whenever we call this function again create user, so this create another closure with this variable, right? So we whenever we call create user function and pass name here, right? So it creates an closure with Alice name, right? Name Alice, and the user score for that variable or that closure will be separate. So whenever we call again create user, it will have a user 2. So the closures are independent of each other. So let's see, whenever we call user 1 add points, right, and user 2 add points 5, user 1 add points 3, right? So it should have user 1 should have 13 number and user 2 have points 5, because both these are independent closures. So let's see, Alice 10 points, Bob 5 points, Alice 13 points again, because we already create closure and we have that function inside this user 1 and user 2 variable, and we can use this user 1 user 2 functions to add more points inside this functions. So user 1 closure name Alice, user score 13 add points function. So these both are same. Each call to create user create a new closure with its own independent variables. User 1 and user 2 do not share state. Common pitfalls: closure in loops. So there is some closure in loops, there is some common pitfalls, like in loops, if we use this in loop the closures, right? This question also sometimes can be asked in the interviews, because this is a edge case scenario, right? So we have where, and where we know is a function scope, so this is a block, right? So whenever we are instantiating or defining where I is equal to 0, I is equal to 1, I is equal to 2, so this is basically adding into the same variable, right? So where 0 and set timeout doesn't run at that time, and again variable I is equal to 1, variable I is equal to 2. So whenever we print this I variable, it will print 3 times number 2, right, after 1 second, because set timeout runs after full loop has been executed, right? So the question can be asked here is, if we want to print 1 2 3 inside the set timeout function, so this is basically a function, so that outer variable I should be accessed inside that, right? So the question here is, if you want to print 1 2 3, so how we can do that? It's with the help of closures, and also if we can use let here, then also it will print 1 2 3, because 0 1 2, because the let is a you can say block scope, right? Block scope. So whenever let is created with 0 I, and it's another variable, it's a different variable, right? And again let I is equal to 1, it's another variable, right? So suppose interviewer asks you that we have to do this without using let keyword. So what we can do is we can create the closure here. We need to create a self-invoking function. Right. So whenever we want to do this with the where, right? So we create a self-invoking function. So we create a closure here. Whenever we create, we know whenever we have inner function and we can have access to the outer variable, right? So whenever where I is equal to 0, so inside that function we have access to this I, right? We are passing this I, we are creating self-invoking function and we are passing I. So I is whenever we are calling this function, right? We learned previously that whenever we call the function, it creates a closure, and it's a closure with the like different variable. So we are calling function with every I. Whenever I is equal to 0, I is equal to 1, I is equal to 2, so we are creating a function 3 times, right? So 3 times it will create a closure and it will have the I 0 1 2 here, because each has its own I now, right? So with the var variable we can do it like this, and let's see 0 1 2. So this is basically how we can use that with the var. Benefits versus consideration. Data privacy. So benefits, what are the benefits of closure? Create private variable that can be accessed directly, maintain state between function call without globals, enable powerful patterns like currying and function composition, right? So it's also enable currying, and we already uh, learned that currying concept in the previous video. I'll put the link in the description, so you can also go through that video. Module pattern, create clean encapsulated code with public interfaces. Closure, keep variable in memory, potentially causing memory leak if not managed. So whenever we create a function, so it creates some closure. So inside that, if we have multiple functions, so it can create keep multiple variables inside that memory, and it can cause memory leaks. Creating many closures can impact performance in extreme cases, can be harder to debug since variables aren't directly accessible, can make code harder to understand for beginners. So essential points to remember: closure is when inner function has access to outer function variable, created every time a function is created at the function creation time, enable data privacy, state persistence, and functional programming techniques. JavaScript maintain a reference to outer scope even after finish executing, where event handlers, callback, module pattern, function factors, and more. Right. Okay, that's all from today's video. Meet you in the next video. So if you have any doubt regarding JavaScript closures, you can comment down below, and I will try to reply every comment. So thank you. Bye bye. Happy coding.